We've seen the images of destruction following a major earthquake, images that often include crumbled and in some cases collapsed buildings, sometimes right alongside structures that look almost untouched. So why do some buildings fail while others stay standing? In many cases, it comes down to engineering and technology.
This used to be the post office.
Take, for example, Pioneer Courthouse in downtown Portland. When it was built back in 1875, it was not built to survive any sort of major seismic event.
If we get the big one, the magnitude 8, like they're talking about,
So,
would it crumble?
If we didn't have any protection, yeah, likely it'd be dust.
But in 2004, the federal government spent $92 million on a project to make sure that would not happen. To see what the feds did, we went inside the historic building, down the first ever elevator installed in the Pacific Northwest,
Go through this way.
into the basement, and then down even farther.
This is the area that had to be excavated.
It's where engineers installed what's called a base isolation system underneath the building. This is one of 70.
This is what it looks like here installed. Basically how it operates is the bottom portion of it is concaved and the upper portion is convex, and there's a bearing in the middle. When the earth starts moving violently, it allows the bottom to move independent of the top, and the building will probably get into a slow sway as compared to a violent action, protecting the building.
In the event of an earthquake, instead of shaking violently, the building will instead sway gently back and forth, kind of like a pendulum. This is an example of a seismic retrofit, taking an existing building, installing some technology, and making it earthquake safer. Head a few blocks away, and up a different kind of elevator.
We're on the 16th floor of the new Multnomah County Courthouse.
You'll find a different kind of quake softening system.
There are about 80 of them.
This one being installed in a brand new building.
But as you can see over here, we have these steel braces which are distributed throughout the building, and at the ends of those braces are these, which are fluid assist dampers.
The dampers work a lot like shocks in your car, so when you go over potholes or speed bumps, instead of feeling a sharp jolt, you instead feel more of a cushion jolt. Well, the same thing is happening inside the building, just with much larger mechanisms to cushion a much larger jolt.
And with 80 of them spread across the building, when the ground below it starts shaking, the damping system absorbs a lot of that shaking, and the building stays intact.
That pulse is translating up the building. As it's translating up the building, it's basically being flattened out, squashed out by the damping provided by these fluid assist dampers.
While this technology has been used to seismically retrofit existing buildings,
This is the first application in Oregon for a new building.
a coupling of modern engineering with both new construction and some old, preserving history and helping to save lives.